Best or world's greatest Algebra 3 trigonometry students. Hey there, Pythagoras, Pythagoras. Pythagoras pen is back here. Also got the Captain Pete hat on, which means today I mean business. Direct some orders. Told Penny this is a big lesson. She's got to really listen up for this one. We're talking about ellipses, Penny. I know that's super exciting for you. And Penny, I don't know if you remember about the different axes, the major and minor axes, but okay, I think we're done. But what we're going to do today here, Penny and class, is we're going to keep talking about these features. We're going to make sure that we talk about what the length of the major axis is, the length of the minor axis is, and then we're going to identify a foci. Actually, foci come in pairs. So the first thing I want to do is I just want to show you, just give you kind of a reminder of what an ellipse is. So here's an example of an ellipse. So you can see this. This is more of a horizontal ellipse. Our major axis is horizontal and our minor axis here is vertical. So our center is right around here somewhere. This top and bottom would be our co-vertices, and then our vertices are here and here. So the thing I want to show you here is I'm going to rotate this point, and then these lines right here are the distance from that point to these other 2 points. So I'm just going to play this scenario out. As this point rotates around here, I want you guys to pay attention over here on the left here where it says D equals. This is the distance from the red and the blue point to this red point. So it's these 2 line segments, the orange and the purple one. If you add those together, this is the distance. I want you to notice as this point is rotating, what's happened to the distance? That's it. It's frozen. It doesn't change. And here's why it doesn't change. The whole definition of an ellipse is that these 2 distances anywhere on this ellipse, the sum of these distances is the same. That's what these are very important. These are called the foci. So what we're going to do is our third thing is we're going to find these coordinates. All right, so enough of that. Let's go back to here. We want to make sure we remember if A is the distance from the center of the vertex, then 2A is the length of that axis. And if B, likewise, is the distance from the center to the co-vertex, then 2B is the length of the minor axis. How do we find the foci? Here's how we find the foci. We use this equation right down here. Letter C is the length from the center to the foci. And if we use this equation right here, we can take these major and minor axis lengths, subtract them. These aren't the lengths actually, yeah. Length squared from distance of center to there. Vertice, distance of center to co-vertice. We'll square them, subtract them, and then we'll take the square root, and that'll give us this length right here, which is super important to find the foci. Okay, 3 examples for us to kind of wrap about today. Captain Pete here. First example looks like this. Find the length of the major axis. Okay, so if we're just trying to find the length of the major axis, it's the larger of these 2 numbers underneath here. This is obviously larger than 9. The length of that axis, well, to find it, we got to take the square root of that. Square root of that number is 5. And that just means letter A is 5. So A is 5. So the distance from the center horizontally here is plus or minus 5 units. So that means the length of that axis is 2A, which 2 times 5 is 10. Find the length of your minor axis. You take the other number, take the square root of that. It's plus or minus 3. That means 3 units up or down. And that's distance from the center. So if it's 3 units up, 3 units down, that double that. That gives me a total of 6 units. So finding the length of our axes is pretty straightforward. We take the square root and double it. Square root, double it. Now the foci is a little bit different. We have to use this equation, which we learned in the previous slide, which says that c squared equals a squared plus b squared. Now we can find a squared by looking up in the equation here. It's the larger of the 2 numbers. We'll substitute that in. B squared, smaller of the 2 numbers. I'm sorry. I did the Pythagorean theorem here. It's not the Pythagorean theorem. Think about Pythagoras' pen here. The equation is minus. Right? So do a little arithmetic here. Got 16, so c squared equals 16. Take the square root of that. C is plus or minus 4. Basically, that tells us the foci coordinates are 4 units from the center. Now, all we need to do is know that the foci runs along the major axis. So here's where a sketchier graph is going to help. If I sketch this graph, I'm going to put the center's at 0, 0. My major axis right here is horizontal, so is the larger numbers underneath x. So plus 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So now my foci length is 4 units in that direction. So our foci is here and here. So I use the graph to kind of help me. What are those values? Those values are positive 4, comma 0, negative 4, comma 0. It doesn't matter what order you write these in. There you go. There's your foci. Okay, so let's do this a similar problem here. Let's just repeat our steps and see how we do. So we'll change up some things. Still want to find all of these. We'll keep this centered at the origin. This looks like it's going to be an ellipse that gets switched. More of a vertical ellipse. Equation, we got a 36 under here, 100 here. So let's just kind of go through our major axis. That has to do with this value right here. Square root of that is 10. I like to put the square roots right underneath here. Square root of that is 6. So plus or minus 10. Major axis, that's 10 units from the center in both directions. Double that, our major axis is 20. Our minor axis here, plus or minus 6 units in the x direction. So we're going to double that. That's going to be 12. Our foci now, remember use this equation, c squared equals a squared. See, look, I already put the wrong number there. A squared is the larger of the two numbers. Minus b squared. We just take these numbers from our equation. Okay, so c squared equals 64. Take the square root. Plus or minus 8. In what direction? Remember, our major axis runs vertical. So as I was to graph this, here's my center. Our major axis is running in this direction. That means our foci are always on that. So our foci will have these coordinates 0, comma, positive 8, 8 units up, 0, comma, negative 8. Boom. Now, this could get tricky. Here's where I could see it get tricky. So we'll just take one more example here. A little bit spicier if the center is not at the origin. We just got to make sure we use our sketch to help us. Right? It doesn't change what we do here. Square root of that, plus or minus 5, plus or minus 3. I always like to do it. Sorry about those notifications. I thought I had those off. Oh, there we go. So our major axis is 10. Minor axis is 9. Our foci then, c squared equals, use the larger number, minus smaller number. That's a squared minus b squared. Okay, what do we get? We get c equals plus or minus 4, square root of 16. That means 4 units in what direction? So let's just take a peek. The major axis runs north and south, or in the y direction, because this number is larger. So my sketch is going to kind of help me a little bit here. The center of this ellipse is positive 1, negative 2. So positive 1, negative 2. I'm going to put it right here. If that's my center, then I know this, that my major axis runs this direction. And that means my foci has to run that direction. So it's 4 units up from here. So I can use my graph to count 1, 2, 3, 4. And then 4 units down here. 1, 2, 3, 4. So this is at minus 6. And this one here is at positive 2. Now notice how I kind of did this one backwards. My x value doesn't change. It's running in the same x value. So there's my foci coordinates. Doesn't matter what order you put them in. Just make sure we can locate those using a graph. So that's it. Stay clean, my friends. Wash your hands, disinfect your phones, and most importantly, be kind.